Hey guys, welcome to day 9. Uh, Today what we're going to be doing is we're going to be looking at a polynomial, and our job is to look at the graph of a polynomial and figure out what its equation is going to be. Right? We've talked about a lot of the different characteristics of a polynomial, such as things like end behavior, the x-intercepts, leading coefficients, things like that. Like we've been able to break these things apart. And we could probably tell a lot just by looking at this polynomial right now. Okay, so I'm going to start building an equation. So an equation is going to start with y equals. Okay, and we can see from the graph that we have some x-intercepts, right? So we have an x-intercept at -3, which tells me that I'm going to have a factor of x plus 3. And you can already start to see an equation coming together here, right? But that's not the only x-intercept that we have. So we need another factor. This one is at 0, so I could write x plus 0 or x minus 0 or just x, whatever you're most comfortable with. And then we have another x-intercept over here at 2, right? So that means we're going to have a factor of x minus 2. So remember, going from x-intercept to the factor, if it was negative, it's going to go to positive. If it was positive, it's going to go to negative, okay? So we have 3 linear factors, which kind of makes sense. That makes it a third-degree polynomial, which is what we would expect to see with the end behavior. Since it's going down on the left and up on the right, we should have an odd degree polynomial. The one thing that we can't tell just by looking at the graph is what the leading coefficient is going to be, right? We don't know what this a value is going to be in front of the parentheses. And that's kind of the mystery thing that we need to figure out today is we want to figure out what this a value is. So that way I can just look at a graph and build its equation just by looking at the graph, all right? So the way that we do that is we pick a point. So when we're given one of these polynomial graphs like this, we want to pick a point that's on the graph somewhere. And I'm going to pick this point right here that's located at 1 and -4. And I'll write that down here. So this is the point that I pick. And you can pick any point that's on the polynomial to do this with. You don't have to pick this point. You could have picked this point as well, and you would get the same result. All right? So what that means is I'm going to take x, and I'm going to let it be 1, and I'm going to take y, and I'm going to let it be -4. So this thing right here is what's called a partial equation, and it's partial because we don't have all the missing pieces. We don't know what the a value is. All right, so I'm going to take this 1 and this -4, and I'm going to go find my x's and my y's, and I'm going to replace those with the value from this point. Okay, so y is going to become a -4. And the x's are going to become 1s, right? So instead of x plus 3, I'll have 1 plus 3, and then 1 plus 0, and then 1 minus 2. Okay, and you'll notice now our equation looks a little bit different. The only thing that is variable right now is the leading coefficient, or the a value that we're trying to find. So this becomes an equation that I can solve with simple algebra techniques. Okay, so the way I'm going to start this, I'm just going to go into each parenthesis, since parentheses come first, and I'm going to simplify a little bit. So I've got -4 equals a, and then 1 plus 3 is a 4. So that parentheses becomes a 4. 1 plus 0 is 1. And 1 minus 2 is -4. Okay, so all I did was, from this step to this step, was I simplified a little bit. Okay, and then I'm going to simplify a little bit more. So I'm going to say -4 equals a, and then I'm going to multiply these 3 together. So 4 times 1 times -4, or I'm sorry, that shouldn't be a -4. It should be a -1. Sorry. Probably thinking I'm crazy. There we go. All right, so 4 times 1 times -1, that's going to give me a -4 when I multiply all of those together. All right, so the last step here to get a by itself is to divide by -4 on both sides. All right, that way these guys cancel. A is by itself, and then I just do this over here. -4 divided by -4 is a +1. So now I know what my leading coefficient is. All right, all I have to do is write my final equation, so I can say y equals, and now I know what this is, so I'm going to put a 1 there, and I'll put my other factors in. So I'll have x plus 3, x plus 0, and x minus 2. And there's my final equation for this polynomial. Right? And you can test it out. You could go to Desmos and put this in, graph it, or use your graphing calculator, put this into the y equals screen, graph it, and compare it to the graph that you have over here to see if you got it right. Okay? So again, just a rundown of that process. Start by building your partial equation using the x-intercepts, right? Use your x-intercepts to build these factors, and then just put an a out front. Pick a point, right? Doesn't matter what point you pick, but pick a point and take those x and y values and plug them into your partial equation here. Solve, get a by itself, and then write your final equation. Okay? So it's a very process-driven lesson. It's a step-by-step kind of thing. And it takes a little bit of practice to get it right, but you guys should pick up on it pretty quick. All right, so we're going to do another one. This one's a little bit more advanced because we have some things going on here. Just some observations about this polynomial right off the bat. End behaviors, right? I'm looking at the end. So on the left side, this thing is going up. On the right side, this thing is going down. So I can tell you right away that because of the end behavior, this is going to have an odd degree, and it's going to have a negative leading coefficient, right? Because it's going up on the left and down on the right. So the a value that we find should be negative, okay? The other thing that I notice here at this x-intercept is that it doesn't pass through without changing behavior. In fact, as it passes through, it inflects, right? It's got that inflection behavior, and we talked about this in the last lesson. This is a triple root, okay? And I'll show you what that means here as I build the equation. So I'm going to start with my y equals. I'm going to put my a out front, and I'm going to build my first factor here. So I'm going to go to this x-intercept here. That one's at -3, so I'm going to have an x plus 3, and it passes through without any change in behavior, so it's just a single root. And then this next one is here at 0, so I'm going to say x plus 0. But this is a triple root because of that inflection, so I need to raise this particular factor to a power of 3 to make it a triple root. Okay, and that's for this root right here. Then we come over here to the 2, right? So we have a positive 2, we have an x-intercept at negative, or positive 2, so we're going to have a factor of x minus 2, and this one just passes through without any change in behavior, so it will be a single root, right? So this is going to be the partial equation that we work with. And the next step here is just to pick a point. So this is the point I'm going to pick right here, and its location is at 1, 5. All right, make sure you pay attention to the scale. These are going up by 5s on the y scale, not by 1s. It's going up by 1 on the x's, up by 5s on the y's. So that's why this point is at 1, 5. All right, so I'm going to say x, y, and I'm going to take those values and plug them into my partial equation over here. I'm going to say 5 equals a, which I don't know. And then instead of x plus 3, I'll have a 1 plus 3. And then for this one, I'll have 1 plus 0 raised to the third, and then 1 minus 2. And now I have something that I can solve for a. So I'm going to go ahead and start simplifying a little bit, just like I did last time. So I'll have 5 equals a. First parenthesis, when I do 1 plus 3, I'll get a 4. 1 plus 0 is 1. Right? And then 1 to the third power is just 1, right? So that whole thing, even though it had an exponent of 3 on it, still just ends up being 1. And then over here, this is going to be 1 minus 2, so that'll be -1. Okay. Simplify a little bit more. All right, so I'm going to say 5 equals a, and then I'll do 4 times 1 times -1. If I multiply those 3, I just get a -4. Okay. Last step here, get a by itself. I just have to divide by -4 on both sides, and the -4's cancel, and this becomes our stretch factor. So I'm just going to say a equals -5/4. It doesn't really matter where that negative ends up here, as long as you know the overall number is negative, which is what we predicted because of the end behavior. All right, so I'm going to write my final equation. So I've got y equals, I now know the a value, so I'm going to put that -5/4 out front as my leading coefficient. I'm going to have x plus 3, x plus 0 cubed, and x minus 2. And there's my final equation for this polynomial over here. And again, like we had predicted, we predicted a negative leading coefficient because of the end behavior, and its degree is 1, 2, 3, 4, 5, right? We had, these are the linear factors here, and we had 1, 2, 3, 4 because of the exponent of 3, and then the fifth one being the x minus 2. So it's a fifth degree polynomial with a negative leading coefficient. So don't lose sight of those things, those easy things that you can identify. All right, for the last part of the video, what I want you to do, I want you to try this one on your own. So I want you to pause the video and try the problem on your own. And then when you resume the video, I'll have the solution over here for you so you can check and see how you did. Okay, so go ahead, hold on here, go ahead and all right, guys, hopefully you are ready and you finished that problem. Let's see how you did. I'm going to put it up on the screen here in 3, 2, 1. There it is. So take a look, see how you did. One of the things I'll note that when I did the problem, there was a double root here because it bounced off of that x-intercept, right? So that means that we had to put an exponent of 2 on this factor to make it a double root. Also, the point that I picked the y-intercept up here at the top. You might have picked a different point. Hopefully you got the same result if you picked a different point, which is fine. You should get the same a value no matter what point you pick on the polynomial. All right, guys, that's it for today's lesson. Try the problems. This requires practice. You might need to try it a couple times in the homework. Even if you get them right the first time, try them again. Make sure you got the process down solid. All right, guys, have a great day.